Welcome, math friends. We're going to be solving logarithmic equations today. As we focus on logarithmic equations, we're basically going to be doing examples that you might encounter, starting off with some basic examples and moving into more complex examples. The main thing to know when you're solving logarithmic equations is the relationship between logs and exponents. Remember that a logarithmic function is the inverse of an exponential function, and we're going to use that combined with one of the properties of logarithms to help us solve equations. If you recall, whenever we have, let's say, log base e of x equals to y, I can rewrite that as e to the y equals x. And then we can use the fact that some number raised to that same logarithm with that same number as the base of x is equal to x. Whenever the exponent base and the logarithmic base are the same, that simplifies to x. I went over how we rewrote to get this in the logarithmic properties video. I encourage you to watch that if you're still a little bit confused by this. So the idea of solving logarithmic equations is to use exponents to get the logarithm away or to simplify the logarithm and have just the variable on one side. So first we want to make sure that we isolate the logarithm, and then we're going to exponentiate both sides. We're going to simplify as much as possible. Sometimes things are very straightforward, like you'll see in this first example, but then you might need to condense your logarithms to get one isolated logarithm on one side. Sometimes you might need to use some factoring or a few more complex strategies. So let's start off with this first example. Notice that the directions ask us to solve for y in terms of x, because we have both variables. And that's important to know, which variable am I solving for? On the left-hand side, I have the natural log of y, and on the right-hand side, I have 2x plus 4. The logarithm is isolated on the left-hand side. I can go ahead and exponentiate both sides of the equal sign to move forward with solving. E to the natural log of y is equal to e to the 2x plus 4. Well, remember, the natural log is log base e. So then I can then use that fact that it is a base e raised to a log base e as well, and that's just going to be y on the left-hand side. It's going to simplify. And I have e to the 2x plus 4. And that's my answer. I'm simplified. It's finished. Y is on one side of the equal sign by itself. I'm good to go. Moving on to the next example, I have natural log c minus 2y equals x. The natural log is isolated on the left-hand side of the equal sign. I can exponentiate both sides. And then I have e to the log base e of c minus 2y equal e to the x. And the reason I'm rewriting it is so that you'll see that those bases are the same, which means I have c minus 2y on the left side equals e to the x. I've not completely solved this equation. I do have y out of the exponent, which is good, but I need to isolate y still. So I need to subtract c from both sides, and then I'm going to divide by -2. If I subtract c from both sides, I have -2y equals e to the x minus c, dividing both sides by -2. That's y equals e to the x over -2 plus -c over -2. And the reason I'm writing that is because I want to actually rewrite it by getting the negative out of the denominator. That's going to be y equals negative e to the x plus c over 2, which I'm going to rewrite as c minus e to the x over 2, just to clean it up. Now, you don't necessarily need to do that. You could write e to the x minus c over -2. I'm sure your instructor would accept that, but this is just, I like to clean it up and simplify as much as possible. You notice that I'm using e to solve these logarithmic functions. If I had log base 10, I would be using 10 as my exponent number. I wouldn't be using e. If I had log base 3, I would be using 3 for my exponent. So it's dependent on the base that you have as to what number you're using for your exponents. E is the most common, natural log is the most common, especially when we get into calculus, but it could be 10 or it could be some other number that you would use, and it's the same strategy applies. Moving on to our next problem, I have log minus a log equals an x plus a log. So I have logarithms in multiple places, and that means that I can't necessarily exponentiate right away. I probably could, but it would be better if I condensed first. And so I'm going to condense this left-hand side by the fact that there is a subtraction sign. And remembering our log properties, subtraction means division. I can combine that to be the natural log of y minus 1 over 2 is equal to x plus the natural log of x. Now, I can exponentiate both sides. I cannot condense the right-hand side because that is not or it's not the natural log of x, it's just x. And so in that case, I'm only able to just take the exponent of both of those. E to the natural log y minus 1 over 2 simplifies to y minus 1 over 2. And then I have e to the x plus natural log of x. That's not as simplified as it can be. Remember that exponential rules say that the plus sign is actually multiplication. I could rewrite that as y minus 1 over 2 equals e to the x times e to the natural log of x. You might be wondering, why are you doing that? Before with the 2x plus 4, you didn't simplify. Why are you doing it here? And it's because e and natural log have a special relationship that will simplify down even further. E to the natural log of x is e log base e of x, which reduces to or simplifies to x. So this piece right here simplifies to just x. So I'm going to write y minus 1 over 2 equals x e to the x. Whenever you see e to the x and natural log, you want to try and simplify as much as possible. I'm then going to multiply by 2 and add 1 to isolate y. Multiplying by 2 gives y minus 1 equals 2x e to the x. Adding 1 gives y equals 2x e to the x plus 1. I have y by itself. I've solved my equation. I'm good to go. My last problem that I'm going to do here, I have a trigonometric function. I have a quadratic. I have multiple logs. I'm going to get to do quite a bit of work to simplify this problem to get a solution. I'm going to use that same condensing here to get the natural log of y squared minus 1 over y plus 1 equal to the natural log of sine x. I notice that y squared minus 1 is a sum and difference that I can factor. And that's going to help me because I'm able to then simplify this expression. And one thing I will say is that y cannot be negative 1. And the reason that y cannot be negative 1 is because I would then have negative 1 plus 1 in the denominator, which would be dividing by 0, which is undefined. So off the bat, negative 1 is not an answer. I'm going to rewrite that as y plus 1, y minus 1, factoring the numerator, over y plus 1, equal to natural log sine x. The y plus 1's cancel, and that leaves me with natural log y minus 1 equals natural log of sine x. I can now exponentiate both sides. That's going to give me y minus 1 equals sine x. Adding 1 to both sides, I get y equals sine x plus 1. And just to be sure, I'm going to go ahead and substitute this back into my equation and make sure it actually works. I then have natural log sine x plus 1 squared minus 1 minus natural log sine x plus 1 equals natural log sine x. Now, you could substitute back in all of your answers to check your work in each of the previous problems, but I'm doing it here because I get something that's a little bit more complex and I just want to double check. Sine x plus 1, foiling that out, I'm going to get sine squared x plus 2 sine x plus 1 minus natural log sine x plus 2 equals natural log sine x. sine squared x plus 2 sine x minus natural log sine x plus 2 equals natural log sine x. I can factor out a sine x from the first expression, and I'm actually going to condense and rewrite this as natural log sine x times sine x plus 2 over sine x plus 2 equals natural log sine x. The sine x plus 2's cancel, and I'm left with natural log sine x equals natural log sine x, which was my goal. It checks out. I'm good to go. I hope these examples were helpful for you. Thanks for watching and have a great day.